So resonance structures are very stable because there's more than one form, and usually the formal charge, in this case the -2 formal charge, is delocalized around the outer atoms. So that delocalization provides for exceptional stability, and it's also, there's not one structure, but the structure is sort of interchanged amongst 3 or 4 different types of structures. So as an example of a hybrid structure is carbonate ion. So carbon is happy at 4, oxygen is happy at 6, but we have 3 of them. So that gives us 18 outer valence electrons. And then the -2 implies that we gained 2 electrons in order to become CO3 -2. So 4 plus 18 is 22. 22 plus 2 is 24. So we have 24 valence electrons that we have to accommodate around CO3. So let's make CO3 -2. So let's make carbon our central atom, because we don't know which of the 3 oxygens qualifies as center. So 1 carbon, 1 center atom, and we'll have 3 oxygens attached to it. Okay, and CO3 -2, and also the carbon is happy at 4. So here the carbon is at 3. So to get it to 4, I'll get a double bond, and obviously a single bond with an oxygen that has a minus formal charge. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, and then this would be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 24 valence electrons. I'm pretty sure we have 24 in here. Let's go ahead and count them to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah, so 24 valence electrons. -2 on the whole carbonate ion. How will we get that? Look at this oxygen here. 1, 2, 3, 4, 5, 6, 7. Oxygen is happy at 6. 6 minus 7 is -1. Okay, same thing with this bottom oxygen. Okay, down here. 1, 2, 3, 4, 5, 6, 7. Oxygen is happy at 6. 6 minus 7 is -1. So here we have a minus formal charge. Here we have a minus formal charge. Formal charge on this oxygen, 1, 2, 3, 4, 5, and 6. Okay, they get counted as 1. Again, 1, 2, 3, 4, 5, and 6. Formal charge. Oxygen happy at 6. 6 minus 6 is 0. Octet rule. Count everything as 1. 1, 2, 3, 4, 5, 6, 7, 8. This satisfies the octet rule. Okay, what about this carbon here? 1, 2, 3, 4, 5, 6, 7, 8. This satisfies the octet rule. And then formal charge 1, 2, 3, 4. Carbon loves 4 no matter what. Carbon happy at 4. 4 minus 4 is 0. So this looks to be like a valid Lewis structure. And the -2 formal charge is satisfied with the -2 charge on the carbonate ion. The only thing here now we have to do is our resonance, realizing that the double bond can not only just be on the leftmost side, but could also be on the rightmost side. It can also be on the bottommost side. So we can draw the 3 resonance structures of carbonate. So I already got 1. Okay, so make sure you put that bracket in there, okay, because these are all hybrids. These are all interchangeable. The -2 is delocalized. The double bond is delocalized across these 3 oxygen atoms. So I got the double bond on here, this end of the molecule, the leftmost end. Let's have it at the bottom. So we'll put this pair of electrons here and that pair of electrons down there. So the double bond now is at the bottom. Okay, now the minus formal charge is situated here, and I really did not mess with this oxygen. Okay, so now the double bond is at the bottom. And then let's have the double bond on this side. In order to do that, I will put this pair of electrons here, kick this one out there, and this will be our final resonance structure. Okay, 3 equivalent forms of the carbonate ion. Now the double bond is on the rightmost oxygen. Okay, notice the double bond, and in turn those two minus formal charges are being delocalized. Okay, they're being delocalized. Here's that minus formal charge, and here's the minus formal charge over here. Okay, so don't forget to put your brackets. Here are the three resonance structures of CO3 minus 2, the carbonate ion, 3 bonds, 0 lone pairs, and this would be an sp2 hybridized carbon. 3 resonance structures of carbonate ion, all equivalent, all illustrating this concept of delocalization. Delocalization of the 2 formal charges, minus 1s, and delocalizations of the double bonds across each of the 3 oxygen atoms.